Grace and Noble.
Now let's discuss about interpupillary distance and how to measure it. Before we talk about how to measure interpupillary distance, in short PD, let's talk about what's a pupil. Have you noticed a black spot in the center of the eye? That is called pupil. Actually, what happens is pupil is connected to iris. Iris expands and shrinks. When iris expands, what happens is pupil becomes small. Therefore, the light that is supposed to enter the eye gets less entry. So, less light enters the eye. When the iris shrinks, the pupil expands. Technically, we say it pupil dilation. So, a pupil is a hole in the center of the iris that allows light to pass through. Distance from the center of the pupil, of one pupil to the other pupil, is called pupillary distance. Interpupillary distance means between two pupils, and it's measured in millimeters. Like all other measurements, this is also measured in millimeter. We measure pupil distance to fit spectacle lenses perfectly so that the patient get accurate vision. So why do we measure IPD? If we don't measure IPD, what happens is the result will be like misalignment, misplacement of the optical center of the lenses, which will eventually induce the prismatic effect. What happens in the prismatic effect is the patient will not be able to look straight. Either he will look on the sideways, outer side, or the inward way to avoid diplopia, yani double vision. Over time, there will be so much of strain, stress, visual discomfort, asthenopia, which means fatigue, and nausea, and all sorts of those things, which the patient will not be very happy about. They will come and complain, and they will tell you what a rubbish lens that you have given. And pupillary distance is measured in various ways. Is one is called the calcospedimeter, the other one is called pupillometer. The simplest way is to use a PD ruler. If you don't have anything, if you have an ordinary ruler or a scale, you can still measure it. Now, talking about binocular distance in IPD, how do we measure it? So, again, just remember the steps. It's very easy, very simple. You have to close one eye. Let's say in this case, you close your right eye. Stay away from the patient for about 40 centimeters. That's called the working distance. All right. Then let the patient see your left eye and use the ruler to point exactly on the right pupil of the patient. Start the right pupil with the 0 point and then until the left pupil exactly measure the distance. So from 0 till the other pupil, you will find about 60 to 70 or even 75 millimeters of distance. If you want to cross check it, you have to close your left eye, open your right eye, and let the patient look into your right eye and do the same, repeat the same thing, and check the distance that you have measured before and the distance that you are going to measure right now are same, or if there is an error. Because accuracy of PD is very important to get a better vision for the patient. So eventually, as a dispensing optician, you check to make sure the 0 point is still correct. What happens is, if you have some problems, some people have problems closing their eyes, that is, closing your right eye or left eye, use your hand. It's very simple. Use your hand on one eye, catch the ruler with the left hand, still you can measure it. If the patient has a problem, some people have squint eyes, strabismus, so you can still tell the patient to use their hands to cover their eyes. Now we discussed about binocular PD, right? Now we will talk about monocular PD. How do we do that? Very simple. You have taken the binocular PD? Yes. Now use the scale. Yeah, close your right eye. Tell the patient to look into your left eye. Okay. Mark the 0 on the right eye of the patient. From that one, take the exact center on the nose. Measure the distance. So if it is 64, for example, binocular PD, which you have already taken before, now you want to measure the monocular. So what you do is mark the center on the exact center on the nose. From there, 0 at right eye pupil. If it gives you, for example, 33 millimeter, 64 minus 33 is going to be 31. That's it. So right measurement is 33, left is 31. This is how we measure it. It will not be more than a couple of millimeters unless there is squint or something else. So monocular PD is done. There's also something called near PD. How to measure the near PD? You need to place your dominant eye in front of the patient. Yeah. Close the non-dominant eye. Place the 0 point on the PD ruler on the right pupil, which I have told you before. Scale the reading at the center of the pupils, right? Now, here there is a 3/4 rule. What is 3/4 rule? It states that for every diopter of the dioptric demand, I will tell you what a dioptric demand is. The optical center of each reading lens, we should be inserting 3/4 of the mm. Don't get confused, nothing to worry. First, you need to know what's the dioptric demand. Dioptric demand is the inverse of the reading distance in meters and is independent of the actual bifocal addition power. If the distance power, for example, for one patient is -1 on the left and -1 on the right, that is OD is equal to -1 diopter, OS is -1 diopter. Addition is +2. Okay, this prescription you already have in your hand. Distance PD is 64 mm. You know now how to take distance PD. How are you going to take near PD? That is the question. For near PD, there is an average working distance which we call as 40 centimeters. Average working distance. Remember this working distance. Average working distance is 40 centimeters. Dioptric demand means very simple, 1 by convert this 40 centimeters into meters, which becomes zero point 0.4. 1 by zero point 0.4 gives you 2.5. This 2.5 add d next to it to indicate that it's a power. So 1 by 4, 1 by working distance is equal to 2 point, don't put minus or plus, 2.5 diopter, which is the dioptric demand. Now, what we need to do, this 2.5 multiplied by, I told you 3/4 of it, so multiplied by 3 by 4. So just take 3 by 4 out of it. That will give you 1.9 or close to 2 mm. This 2 mm on each lens, just subtract it. 2 mm on the right, 2 mm on the left will give you the near PD. So if you are having 64, for example, as a total distance PD, let's say 32 and 32. So if you are deducting 2 on the right, this becomes 30, 2 on the left, that becomes 30. So the near PD on the right is 30 mm, left on the 30 mm. In case if the near PD, if the distance PD is 33 on the left and 31 on the right, then 2 deduction of 2 will become 31, deduction of 2 on the left will become 29. So this is the near PD. That's simple. Alright, so the easy way is to deduct 4 mm from the distance PD will give you the near PD. Alright, thank you for being with me, and we'll be now going forward to know more about, there's a lot of things to know. One is about contact lenses, the other thing is about the value additions. Value additions means I'll be talking about polarization, I'll be talking about anti-reflection coating, I will be talking about high index lenses. So lots of things, it's a wonderful field, I'll tell you guys, really wonderful, and you'll benefit a lot by knowing more and more. Have a nice day.